Okay, so this 23 is a really good problem. You need to know your type 1 and type 2 errors, all right? So I suggest you memorize that and dump it down as soon as you get your test. All right, so they want to know which of the following here is a type 2. Well, type 2 error is, I'm just looking here at the answers to make sure I get this right, that HO is false, but you go with HO. So if HO is false, that means HA is true. So a person has arthritis, but what do? You misdiagnose them that they don't have it, and that is B. Okay, so let's talk about this. We have green stink bugs, and we have brown stink bugs, and both of them are 20. Both of them have a mean of, well, the green one has a mean of 16.22, and then the standard deviation of 1.34. And then the brown one has a mean of 13.41 and a standard deviation of 0.73. Okay? So let's look at this here. And they want us to find the standard error. Remember, the standard error is a standard deviation. So what do we know here? Remember, we have to bring it up to variance, okay? So when we bring it up to variance, notice here they just wrote everybody squared. So it's going to be 1.34 squared over 20 plus 0.73 squared over 20. Now, if I add these two together, remember we have a common denominator. So it's going to be 1.39 squared plus 0.73 squared all over 20. Now, because this is invariance, you have to bring it to the square root, the standard deviation, until we take the square root. And so the answer here is C. Hopefully you realize that we don't subtract. Okay, let's look at this here. We got several things going. We got 9 volunteers, and they can't tell the difference between the two waters. So that means to get it right is going to be 50-50, correct? And they want to know at least 8 of the 9. So the probability that X is going to be at least 8 is equal to the probability that X is equal to 8 plus the probability that X is equal to 9. All right? Now, the probability that X is equal to 8 is going to be 9 choose 8. Okay, so we get 0.5, because remember it's a 50-50% chance that you get it correct. And then there's a 50% chance that you get it wrong. And so 9 minus 8 is 1. So this is for 0.8 plus, and then I'm going to get 9 choose 9. It's going to be 0.59, then 0.50. Okay, so I am going to go to my calculator under distributions, and I'm going to go to binomial, but it's going to go to CDF because it's cumulative. It's more than 1. All right, so I'm going to go to my graphing calculator, and I'm going to go to distributions, and I'm going to go to binomial CDF. My trials is 9, my probability is 0.1, and my X value is 8. And this will give me 8 and 9, okay? So I get 0.9980, which is E. And the answer is B. What did I do wrong? Okay, I figured out what I do wrong. I got an 84 here. Okay, so the 84 starts at 0. So I found 0 to 8. And I want 8 and 9. So what I have to do in my graphing calculator, I'm going to have to do 1 minus. I used to have to teach this. So this is where, so the trials is A, and I'm going to go to 7. And I get 0.01985. That's it, B. Okay, it's easier on the inspires. Okay, number 26, I think, is an interesting twist on confidence intervals. So you have somebody, 100 students and a 99% confidence intervals. All right, and so we know the population proportion. Well, we're confident, but we're not sure. Okay, it's not in there. And the deal is, we know that it contains a sample proportion, but that is not what we're interested in. Okay. I think the answer is B here. The population proportion are equal. We don't know that for sure. And the probability the sample would be equal to. Okay, so why is the answer B? Remember, that's the thing about confidence intervals, that after repeated sampling, 99% of the confidence intervals will contain the truth. So B is the answer.